Yes, hi everyone. Thank you for coming. Python for Data Sciences. So today we're going to start talking about pandas, and we're going to do some plots, math plots, and how to plot your data. And the next few lectures will be about data science, data analysis using pandas, NumPy, matplot, and so on and so forth. All right? Please try your best to do some exercises when you go home. It needs a lot of exercises. So before you start, to be able to do the exercises in here, I'm not sure what compiler you are using or what tool you are using to compile your programs. I'm using the Charm. So you have to add the modules that you need to use. For example, this is in here NumPy. I added it. The pandas. Where's the pandas? Do you see pandas in here? Pandas is in here, right? You need to have the Seaborn. Okay. SciPy. You're gonna need it later, and you need also the matplot. So five libraries or modules that you need to add. And if you are using the Kindle or the Endo, the default tool comes with Python. You need to use pip install for these modules. From here, you have to hit the plus here. Okay, and add the module, right? So you could hit the plus and search for whatever you like. In here, for example, pandas, okay? In here, but I have it installed. I don't have to install it again. Okay? So that's what you need for this, okay? So what is pandas? I mean, like when we work with data science, when you work with data sciences, data usually is can one of you bring one from the other classroom? Something really is.
I think you need some water for this, maybe.
Man, no, it's really weird. It's like making a mess. I have no idea what's happening. Okay, when you work with the data, right? So usually you have, like, for example, you're gonna have columns. So if you're talking about the student data, you could have, for example, first name, last name, student ID, date of birth, address, right? Okay, and then you're gonna have many samples. Okay, so you could have first to up to whatever 100,000 people, 100,000 students, 1 million students. See it will work?
See, I don't know. No?
No, I think something wrong with. I think they cleaned this with something, make it work. I'm not sure what's the problem. So it's not the. I don't know what's the problem. Okay. All right. So right. So you could use Excel sheet. Okay, except in Excel sheet, there is a limit for the number of records you could have. I think million and a quarter. Okay. When you work in deep learning, machine learning, you're working with a data sample or data sets, we call it. Like you could have like 5 million, 10 million, right? And these things you need to load it in your program because you're gonna do some operations on that. All right, and it has to be efficient. So using less, Python less, will not do it. Okay, it will be very slow. It will not do that. So we come with different specialized packages like NumPy, pandas, and that's their job. You'll be able to create a data frame. So this is what we called it. This one we call it basically in the language of the data. We call it data frame. All right. And the data frame built of series. So this is what we call a series. Okay, so multiple series. Each data frame built of rows, okay, and columns. or we call it series. It's like a series, all right? And in pandas, you'll be able to create these. You'll be able to read them from files. Usually, like this big data set, saved enough files. You need to read it in your data frame, and then do whatever you want to do with it, and then save it back to where in the data in the file, in the term or in the shape of file. The most common format for a file is like comma separated file, okay, CV, CVS, so C. What's going on? Okay, comma separated values, all right, or it could be tab separated values, all right. You could save to a binary file values. All of these are available. You could do all of these, right? Later on, when you advance, you'll be working in machine learning. So, how does machine learning work? What is machine learning? Any volunteer?
We have a program that sees some data and starts seeing patterns in the data and learning from it.
Learn from the data, right? So for example, let's say for example, like you go to the mail system, to the mail office, all right, they receive the mail, right? So, I mean, they try to distribute the mail. So do you think there's a person read and put like, for example, this is in this box and this box and this in the box? No, there are machines. These machines are trained to read like you read. Okay, the problem, you are as a human. So if somebody writes for you like 9 like this, or 9 like this, or 9 like that, you'll be able to figure it out, right? But how we can train the machine to read all possible kind of 9s, or 0s, or digits, right? So basically we have a machine with a scanner that becomes smarter, becomes smart, okay, intelligent, okay, machine learning, it's learned, right? How are we gonna learn? We have so many samples. We collect the samples, for example, for all the digits. Okay. For example, let's say that 9. So let's change this to. Couldn't you find another classroom, different one, please? Maybe if there's a problem with this. Just any classroom.
Actually, it's nothing to do. I think it has to do with the board. What
problem with the board? You think?
I think so. What I'll do is I'll get like a paper with some like water so that
anything. Yeah. I don't know what's the problem. So for example, we have this is for example 0, 1, 2, 3 up to 9 digits. So we have, let's say that we have like 10,000 samples. For 0, 10,000 samples for digit 1, 10,000 samples for digit 2, and so on and so forth. All right? So these are all possible samples and how to write the digits. Right? So what we do, we create a machine learning system. All right? And we train it using this data. How to train it? There are so many algorithms for training this machine. All right? Then after that, you test it. So usually, let's say that you have like 10,000 samples. You take 7,000 samples for training and 3,000 samples for testing. If let's say it gives you accuracy 99%, then here you go, you have a very good machine that is trained and you could apply it in your system. All right? If it gives you like accuracy, let's say 60%, that means it's not that good. Still, you have to have a better model training for the system that gives you more accuracy. So, how you do this training? Using these models. What are these models? They are algorithms. How they are written? By Python. What do you use what do you use for this model? What do you feed this model with? Data set. Where is the data set coming from? In files. Okay? So what you have to do with these files? You have to read them in your program, in your Python. How you read them in? pandas. You save them in a data frame, and then after that, you do whatever you want to do. Right? Okay, so that's what is pandas. So it's if you're gonna call it Excel of Python, call it Excel of Python. If you're gonna call it a matrix of NumPy, call it a matrix of NumPy. We call it data frame. Clear? All right. So going here quickly. So we know that we have like we deal with data frames, as we said in here. We deal with series, which is the columns, and the data frame. The data frame represents the entire spreadsheet that you're trying to load from a data. Yeah. It's really weird. I mean, I don't know what's happening.
I have seen it before.
Oh, really?
Yeah.
I don't know. I mean,
So try this. This is a
I
little bit
think,
wet.
let me see this.
No, it has to be wet. Yeah, somebody has messed up the board.
Yeah. So, let's see. I'll try not to write in the board, that's fine. So,
Someone probably cleaned it with
all right.
something. Somebody probably cleaned it with something.
Yeah, something it's like, and it's like,
a permanent marker or something.
yeah, yeah. Now I have to remove this part from my video. So, all right. More work, okay? So, all right. So basically, to do your work, what you have to do, you have to import pandas. Make sure you import pandas, okay? And usually, the way we do it for shortcut, we don't want to type pandas. We say import pandas as PD. So the PD will precede every method and attribute we gonna use, right? So now, as you said, most of the data coming from where? From files. And the most common file for the data, you get from the data set, is like in CSV, right? CSV. So there's a method called CSV that you could read the data from. So in here, for example, okay, what is the first thing you have to do? Import panda as PD. Then I have to get the data from a file. So I have a file saved. I have a file saved in my computer, in your computer, which is extension TSV, which is tab, separated value. If it's not a comma, I have to tell the separator is a tab. And then this is the path. I put the path for the file. And the way I do it, okay, pandas, okay, dot read CSV, that's a function. I'm gonna read it, and I'm gonna save it where? In the data frame. Give it a name you want. From now on, the data will be brought from your file to where? To your data frame in here. All right. So let me go on here. So let's say file here. Okay, let me call it test. Okay, so the first thing you have to do, import pandas as PD. Good? Okay, as PD. Okay, then after that I need to bring the file, okay, which is, what is the file in here? Okay, it's okay, so df, I'm gonna save it in a data frame, okay, and I'm gonna call the module PD, and the function is read underscore CSV, all right, and I have to put extension for the file. The file, it's a tab separated. So I have to say separation equals \t. So I go in here, okay, separator equals tab. All right. Now what I have to put in here, what is missing? The path for my file. So the path of my file, actually I wrote the program in here, so it's in here. I saved it in this path, very simple, let me cut it in here. Control copy, and I'll put it in here, alright? Okay, so I imported the pandas, and I'm reading the data frame from this file. Let's try to run it. There is a syntax error. What's a syntax error?
It has to be between quotes.
Between two quotes. That's correct. I forgot the quotes, and I have to put in here a quote. So let's run it again.
You didn't add the code.
Oh, did not. Okay, sorry.
You
At
have
the end.
one extra code at the end.
I thought I added the code, no?
Yeah,
Oh,
sometimes when
it's
you
added
add
in
it,
here. That's
it's
I see what's
automatic.
happening. Okay, added both of them. Okay, that's fine. Sorry. I mean, the screen is like white. I can, okay. All right. So I read it now. Okay. So now it's in PD. Now from PD I could do whatever. So if I need to display what's the data, okay, how can I do that? Very simple. You could say print df.head. The head will print the first record for you. Okay, 5 records. So, okay, so df here. Okay. Okay. Print df.head, and let me run it. All right. By default, it will print, you know, in here, if you can see in here, it will print, okay, the first 5 records. All right. If I need to print the last 5 records, I could say tail. Okay. So 1 here to print in the last 5 records in the program. The 5 records in the program, right? Okay, I could, if I need to print, for example, the last 20, I just put the 20 in here, and it will print to you the last 20 records. Okay, there's no problem, right? So, and I could do whatever. So what you see in here, let me print the head. And this print only the 5. Just need to take a look. 5. Okay. All right. So what do you have in here? You have 5. You have 5 lines, 5 rows. Okay. And each row has an index. The index starts from 0. That's it's given 0, and ends by 4. Right. So it starts by 0, and because you have 5 records, it says by 4. And each column will have a label. So you have country, content, year, life expectancy, population, and GDP per capita. So how many columns we have? 1, 2, 3, 4, 5, 6. Okay, and how many rows we have in the data? A lot, right? How about if we say shape? Okay, it has 3,313 rows and 6 columns. All right. So there's so many attributes that you could, you know, investigate the attribute. So, I mean, if I need to type everything in here, I mean, I will not move. So I need to go to the PowerPoint. I mean, I know it's nicer that we try everything, but it's up to you when you go home to try every thing there. All right. But I have created a nice snapshots for you for all the codes. So please, and I put them in purpose, like a GIF that you cannot enjoy cut and paste, right? Okay, so you should not enjoy cut and paste. You should type them to practice. Okay, so look in here. So we have the pandas read. We read the file, and you could print the file as you wish. All right. So load a simple delimited data file. All right. The good thing, always function, and I use it a lot of the time. All right, because sometimes when you write programs and you do conversion from a list to to a series to a list, to NumPy, to different things, the type. So if you do type for the data frame we have created, it gives you a class _ frame data frame. So this is a data frame. Sometimes you'll find it's a series, sometimes it's something else. So it's a very important while you're writing your code, always to investigate what you are trying to do. Every data frame object has a shape, and that's what we did. So df, there is attribute called shape. Is this shape attribute or a method? Attribute, because the method has to have parentheses. So, all right. So it's like in this one, loaded in here different streams than there. There's about 17 or 4 different rows. All right. Okay. So that's what I'm trying to tell you. If I put like 2 parentheses in here, will give you an error because shape is an attribute. All right. It's not a method. All right. It's a shape, not a method. Okay. So if you would like to know the columns, the head of the columns, what they have, the head of the columns, what they do have, each column has what in top of it? A label. And a label, right? So label. So if I need to know what is the labels, so I could use the attribute columns. Columns will tell me the labels. Okay, so when I say df.columns, what gave me country, continent, year, life expectancy, population, and GDP per capita. And what is the type? It's an object. It's an object. Good so far? Okay. Okay. Now, what do you expect the first thing you need to do when you have such a huge data? Subnetting. Usually, for example, you'll be working in one of the columns, or you'll be working in, for example, a set of the rows. Okay, so for example, you would like to work in the African countries, not in all the countries, right? Subnetting. Did we do subnetting before? Did we do subnetting before? Yeah, we did, and you have a question in the exam. Subnetting, right? We did a lot of subnetting, right? So for example, when we have a list, for example, list L, for example, equals 1, 2, 3, 4, 5, right? All right. So when I do like this, what does it mean? All the data, right? Okay. So we did subnetting a lot. I mean, and it's the same thing. I mean, there is 3 ways to do subnetting in here, but we did subnetting a lot. Subnetting is like, selecting part of the data, not all of the data. All right, so subnetting columns, if we want only a specific column from our data, we can access the data using square brackets. So for example, okay, I need to have only the column of country, only the country. So df, subnetted country, and the label always we put it between 2 quotes, all right? And I'm saving it where? In a variable. This variable will be what? Country data frame. Country data frame. All right. If I need to print it, if I need to check what I'm having, so country data frame, which is I saved in here, dot head, and gave me what? Only the country. All right. The default is the head will give me 5 records, because it will not clutter all the screen. Some of the files will have like millions of records. If I really need to print all of the data in that column, what should I put? I have to put head and the number of rows, right? Number of rows. How can I get the number of rows?
Shape.
From shape. So shape and shape of 0. Because if I type in here, so in here shape, and if I put like this 0, what it will give me? The number of rows. If I say 1, the number of columns. All right. All right. So I'm not going to open a file that has 5 million records and count how many rows, right? I use the shape, and from the shape I try to get the number of the records, right? So I could have it there, right? So that's what you do, right? Any questions so far? Okay. So, all right. And to print, can you see in the back? I mean, I'm surprised. Can you see? Sure. You have it there, right? I can't see anything for some. Oh, that's good. Can you see, guys, the board? Okay, you sure? Something is wrong with the accent. I mean, I'm next to there. Can you see? Can you read it?
I can. Yeah.
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 Yeah. All right. Okay. So in here, if you have the tail, okay, it will print the end of it, right? Let's move on quickly. All right. Looking at columns, rows, and cells. So we have like a data frame built of columns, rows, and intersection of a column and row is the cell. So subnetting rows can be subnet in multiple ways. There's a functions for that. The first function is called the lock for the location. So there is lock and iLock. Lock for location, iLock is for index location, right? So I'm here. What I'm trying to do, I'm trying def lock 0. So what I'm trying to print in here, print the first record. The first record, all right? And what is the first record? The country is Afghanistan, the continent is Asia, the year is, life expectancy is, population is, and so on and so forth. So I could access one record, or I could access a group of records, right? So index of data frame in Python starts from 0, remember all of that. So in here, print data frame, which we loaded the data to it, and location 0 gave me this. All right. About if location 99 will give me that. There is no problem. You could pick any location you want, and if I need to get the last row, that's what just I explained to you how to get the last row. Is very simple. So first of all, I have to do the shape of 0. That will give me what? The number of rows. I saved it where? In a variable, number of rows. All right. Then last row index, okay, it will be number of rows minus 1. All right, because it's gonna give me, for example, 100. You understand? Minus 1 because the index is minus 1. So if I need to have it for the last one, it's very simple. Data frame dot lock, that means the location, and I have the variable where I stored the index, and gave me the last one. Stop me if I'm going fast. All right. The better way sometimes to use the iLock. The iLock is numbers. All right. All right. So lock in here. When you look at the shape, let me go in here back. In our example, in here, for example, let's say head. Go back to head. Okay. So in here, when the index, the first column, the index is a number, which equals to the index. Does not make a difference, right? But you could create data frame where you have the index in here is a value, not a number. A value, right? So let's say that we have a data frame of celebrities. You know celebrity, right? Celebrities. So you don't have, for example, the index will be indexed by the last name, or by the famous name, or by the common name. All right? So in our example in here, iLock and lock will not make a big difference, but in many other situations, it will make a difference. So, all right. So iLook, okay, does the same thing as look, but it used to subset by the row index number, not value, number. In our current example, iLook and look will behave on exactly the same way since the index labels are the row numbers. However, keep in mind that index labels do not necessarily have to be row numbers. You could change that, right? So the same thing, if I need to look at the second row, I look 1. Okay, because 1, it means the second row, and give me the list there. In here, in iLook, I could access the last record by -1, like we did subnetting before. So -1 in any subnetting in Python means the last record, right? So in here, when I say df.iLook -1 means the last record, printed for me the last, yes.
So the iLock is always going to be a number, but the log can also be another value.
Exactly. It will. So in our example in here, the index number and the index value are the same. So both work, but in other examples will not work. All right. So I would like to print a range of rows. So in here what I did, for example, range 5. So range 5, give me what values it gives me. 0, 1, 2, 3, 4, right? I converted it to list. Why did I convert it to list? Huh? No. Because range, what does return to me by default?
Number of items.
Range returns tuple? Or not a tuple.
Generator.
Generator.
And generator are generated on the fly, so it will not work in here. Okay? In Python 2, it returns a list. In Python 3, it returns a generator. So for that, we have to cast it to a list. So anyways, what we have in the small range? A list. What is the content of the list? 0, 1, 2, 3, 4, right? So that's what the code. So print small range, it's a list now, right? So I need to subnet, right? So DataFrame.iLook, all right? There is a comma in between. To the left, it will include the rows, and to the right, include what? The columns. So that means in here, when you say in here a column, that means it will include all the rows, and in here will include the first five columns. So when you look when it's printed, you're gonna print all the rows because we put column, everything, right? And how many columns it has? 1, 2, 3, 4, 5. We are missing the 6th one. The reason for that, because we selected only 5 columns. If I need, for example, to print 3 columns, so I have to use range 3, right? And so on and so forth, right? So while range function can be used to create a generator and convert it to a list of values, the colon syntax for slicing only has meaning when slicing and submitting values and has no inherited meaning. So in here also, 3. Okay, so in here, when I say range of 3, I have 3, yes.
What about pulling specific columns that aren't in order?
Sure, you could. Just list them in here. Okay,
By
so-
name?
By name,
By index.
if it's log.
Okay.
In here by index. So if you need, for example, to have the year first, I'm not sure what year, it's number 3, right?
Yeah.
So put 3, then the country, whatever, number 0, 2, then number 0, then number 1. The way you list them there, right? So in here, I'm printing all the rows, and in here I'm printing how many columns? 3 columns. Okay, 3 columns. All right. Okay, get the first and 110th rows. So what is the best way to do it? Lock or iLock? iLock maybe, because you are using that index. All right, so how you do it? Okay, data frame, index location. All right, so I'm looking for how many, which records I'm looking for? How many rows? 3 rows. The first, number 100, number 1000, comma, and what are the columns I'm looking for? That's your question.
Okay.
0, 3, and 5. So that's 0, which is country. Okay, which is not column number. Column number 4 was life expectancy, and column number 6 is GDP. All right, and of course you printed the 3 records. The 3 records. All right. So look in here by the label. By the label. So for by the label, what do I have to use? iLock or lock? Lock. So lock the 3 lines, the 3 records. Number 1, number 100, number 1000, and then here what they included, the labels. The labels. So it depends on your program requirement. Sometimes you would like to use like labels, and sometimes need to use the indices. All right. Okay. So it gives you all the data. You have to try all of this, by the way. You have to try it and all of that. All right. So in here, what we are trying to do, usually in database, when you have like big records, what is the most important thing you do? Grouping them, right? You'd like to group, right? So if I would like to include calculate, for example, the average GDP in Africa. So I have to combine the African countries, add up the GDP, and divide it by the number, right? Or I would like to, for example, get some information about, specific to a continent. I could do that. So in here, for each year in our data, what was the average life expectancy? What is the average life expectancy? So how we do that? So the data frame we have to group it by year. So what we do first, we group by year. So depends on how many years I have in the database, I have how many groups, right? So group by the year, then I sublet by the life expectancy. So I group every year together. Okay, I look at the life expectancy only, and then I calculate what? The mean, the average. And when I print it, it will give me the year. So in my database, I have how many years? 1, 2, 3, 4, 5, 6, for example, and calculated for me what? The average of the life expectancy for that year. For that year. What do you notice with the life expectancy? Increasing as the years increase, right? So the life expectancy, for example, the average in 1952 was 49 years old, and in 1977 was 59. All right. Nowadays, maybe it's much more higher. All right. So that's the idea of the data. You manipulate the data to get information from it. All right. So group year. So in here, if you look at the year, let's look at close that. If I group by the year and I print the type, group by the year, and I save it in a variable, I print the type, okay, it will be a data frame group by, a different object called data frame group by. All right. If I printed it, it will give me the memory allocation. It will not print the data. Why? Because it's not a data frame, right? It will print the memory allocation for it. So let's take a look at pandas data structures. Okay. So, when you work with pandas, either you work with series or you work with data frame. Series is like it's kind of one column. Okay, or data frame which is like a matrix, So Panda series is one-dimensional container similar to the built-in Python list. It's similar to the Python list. It is the data type that represents each column of the data frame. So each data frame, as you see in here, is built of a group of series, So in our example that we ran, okay, we have how many series? 6 series, right? Because we have 6 columns, 6 series, 6 columns. Okay. The easiest way to create a series is to pass in a Python list. So for example, in here, PD, okay, series, PD for pandas, series, and I'm passing a list. The list how many elements has? 2 elements, panda, like a string and integer. We don't call it a string in pandas, we call it object. So the string inside panda, we call it object, all right? And this we call it integer, all right? So I have created in here a series. If I say print s, it will print the series for me. Always will give it index 0 and 1. If I have like 5 elements in here, I will have 0, 1, 2, 3, 4, 5. All right? So that's a series. So the easiest way to create a series from a list. All right. Manually assign index values to a series by passing a Python list. So for example, in here, this is a series. I called it S. PD for panda, series, and I called it S. So what did they pass to it? A list. A list, how many elements it has? 2. With McKinley and the creator of pandas. All right? What are the titles of these? We don't know. If I need to give them a title, I use the index. So what will be the first element? Person name. The second, who. So when I type the series I have created, the person is Wes McKinley, and the who is creator of the pandas. If I remove the index in here, and I print it, will give me what? 0, 1. 0, 1, right?
Looks like a dictionary.
Like a dictionary. Yeah. Okay.
And it's automatically formatted that way?
Yes. If I flip these, so West will be who and person will be that, right? All right. Data frame can be thought of as a dictionary of series objects. Dictionary of series objects. So dictionaries are the most common way of creating data frame. So to create a series, we use a list. To create a data frame, what we use? Dictionary, right? Dictionary. So look in here. So scientist, what is a scientist? A data frame. Scientist now is a data frame. So PD for panda, and to create a data frame, we use data frame, D capital, frame, F capital. All right? And now I'm putting dictionary. So name, and then passing how many elements? 2. Ruslan, I think this is Ruslan Franklin, and William Gossi, I think, and the occupation, chemist and statistician, born, dates, died, dates, age 36, 61, you know, okay. So in here, how many columns they have? How many series they have? 1, 2, 3, 4, 5. Right? When I print scientist, what is scientist? It's a data frame. Okay? They're printed 0, 1. Okay. Why? Because they have 2. Then what are the titles? Age, born, died, name, occupation. What do you notice in here?
Out of order.
Out of order, right? Why? Because always dictionary out of order. Dictionaries, when they are created, out of order. They are not ordered dictionaries. Okay? If I need to have them ordered, what they have to add in here? Index. If I add the index, okay, or I could convert the dictionary to ordered dictionary. I have to import a library, a module, and then I have to create an ordered dictionary. But dictionary by default, we learned that long time ago, dictionaries are not what? Yes.
So in this case, it's printed by alphabetical order. Is that coincidence or
Not necessarily.
So that was just happen. It could happen anyway.
Yes, yes, not necessarily. All right. All right. So in here, for example, if in here creating a data frame, in here scientist, data frame, data. So data. What is data in here?
Dictionary.
A dictionary. So I'm creating a data frame from a dictionary. Incubation, born, died, whatever. I add the index. So now the index will be what? Will be the index values, not anymore 0, 1. Remember what I told you, that you could, the data frame could be indexed by numbers. If you don't add an index, by default the system will add index 0, 1, 2, 3, numerical index. But if you add an index, whatever you add becomes the index. So what I added in here, the index is and how many columns here I have? 1, 2, 3, 4. It's not a column anymore, it's an index. So it's 1, 2, 3, 4. These in here are indices. Label indices, not the columns anymore. So there is a difference. So there's a difference between this. This has how many columns? 5. 1, 2, 3, 4, 5. Right? In here has how many columns? How many series? 4. 4. Okay. All right. How can I double check? Shape and shape. Shape and shape. Right? Will tell me all of that. Clear so far? Are we still friends? Okay. All right. So, in order, the order is not guaranteed because Python dictionaries are not ordered. By default, dictionaries are not ordered. If you want to order dictionary, we need to use order dictionary from a collection. So you have, there's a collections module you could include, and it could do that. Very simple. So in here, for example, scientist, panda, data frame, and I'm calling what? Ordered dictionary. Ordered dictionary. To be able to do that, I have to import the collections. And then I could call the ordered dictionary. The same thing. Now what you notice, we start name, occupation, born, died, age, name, occupation, born, died, and age. They are ordered. Right? So watch it out. I mean, when you create, make sure that you know what you are doing, right? Good? All right. So you could have a row index also in here, the same thing, occupation. So scientist, occupation, born, died, age, index, that's a row index. And in here you're putting the columns, you're naming the columns. Okay, occupation, born, died, and age. Okay. All right. We create a data frame that slice it to get the series. So for example, all right, in here what you are doing, all right, so first of all we're creating a data frame, we're calling it scientist data frame. This is a dictionary. Okay, there's index and columns. And then when I say print scientist, which is the data frame, it will print it in here as normal. Okay, and in here create our with a raw index. This is with a raw index column scientist. Same thing. I'm not sure what I'm doing in here. In here, yeah, I'm printing the location by the label index. So scientist, look, it's not iLook. Look, if I put iLook, what should be in here? A number. Okay, so location, William. How you read this? Gaussy? Everybody knows Gaussy or Gosset? Gaussy. Okay, so when you print it, it will print one record for you. Alright? It will print a one record for you.
If you use just lock, it can't be a number.
It cannot be a number.
Okay.
Okay, it cannot be a number. Only in one case. See, the label indices is still a number. Okay, you could use that, but it will be as a text.
Oh yeah. Okay. got it.
Okay.
Yeah.
We create a data frame and slice it to get series. All right. So for example, in here, you have scientist is a data frame. You have a dictionary to create it. You have the index. Okay, you have the column here. When you print it, will give you this, same thing like before. Then let's slice it. So in here, we're doing the first, we are trying to get the first row. So we're gonna use the lock, and we use the label index, and the label index, so the label index will be, the row will be saved in the first row. And this will be a series. So first row will be a series because it has one row. That's one row, it will be a series. If I say print first row, print the series. So if I slice one row from any data frame, the type becomes a series. If it has more than one row, it will be a data frame. It will be a data frame. A good advice, the print type method, a function actually in here. It's a very good way to use it. You get confused when you write your code and you like slicing, creating series, sometimes converting to a list, to a dictionary. Always try to just verify what you are doing. All right, verify type. Okay. So in here, series method usage example. So when I say print ages the mean, what is ages? Right? The age, right? So if I need to calculate the age, okay, there's a file ages. I think there is another data set I forgot to mention here we loaded. Okay, you can calculate the mean, the minimum, the maximum, the standard deviation from that. There is a lot of series methods that you could use. Okay, so for example, so far we use the max. Okay, all right, just be logical. Okay, when you need to apply a max on a series, the series has to be what? Has to be numbers, right? Ages, like for example, right? Okay, if you use the mean, the same thing. Median, mode, quantile, replace, sample. So histogram. You could create a histogram from that series. Graph. Okay, what is histogram? Like a pinned
Bar chart.
It's not a bar chart. It's like a pin chart. It's like, for example, I cannot write it.
John, you already said.
Huh?
Maybe that side.
Shall I run it for the next person too? Yeah. All right. So for example, you know, it could have like this. Like pins. So for example, you know, here there is and here. Okay. How many? You know, like this has for this range has like 50 counts. This is have 30 and so forth. Like pins. Okay. So like ranges. Okay. All right. So many and maybe there is more, much more. Values, right? Unique, whatever, and all of that. Okay, you could use them a lot. All right. Any question about series? All right. No questions. All right. So, vector of the same length. So if you perform an operation between two vectors of the same length. So when you have a series and series, I mean, vector is like a term used by NumPy. Series is used by pandas, but you know, pandas came after NumPy. It's like improvement for NumPy. Okay. So vector, and so if you need, for example, ages, if you say when you do ages times ages, what does it do? It will go from the first cell with the first cell of the other vector and multiply them together. Second, like kind of broadcasting. Second, so you don't have to create a loop. You don't have to create a loop for that. It's gonna go. So in here, okay, the resulting vector will be an element by element calculation of the vector. So if I have like a vector ages, I'm multiply. So in here, what are the ages I have? Okay, what are the ages I have in here? Where is my data? 37. 37 times 37, and then it does, for example, 61 by 61. That's what it does. All right. So it will multiply the first element with the sub. I'd save it in here and so on and so forth. Right. If I say ages by 2, what does it do? Multiply by 2, element by element. Okay. So this is like vector by vector. All right. And this is like scalar. Scalar. If I say ages plus PD series 1 and 100, the element, so series, the element number 2, and the element number 101, right? So it's gonna add, this is not equal, so this one is not equal to this. This has how many elements? This series has many elements. This has how many elements? 2. So it will add, you know, actually this is yeah, it will add, you know, series. Okay, this is creating a series in here. A series. It has 2 elements, 1 and 100. It's not reading from another series. Okay, so it will add 1 to the 37, gave you 38, and will add 100 to the 61. And will give you 161, right? The rest, there is no elements, it's not going to do anything. So, no number. There is no available number. Okay, we'll add that. Vectors with common index labels. So, for example, print ages. I have 8 elements. All right, and here, reverse. If I need to reverse the ages, for example, ages dot sort index ascending false, so it will be descending. Ascending false will be descending, so it will print it for you in a descending way, in a descending way. Now, the funny thing, if I multiply it by 2, if I multiply ages by 2, it's not going to operate on this, it's going to operate on that, because it will maintain the order. It will maintain the order.
Can we,
Yes, you can.
so we created a variable called reverse ages.
Yeah.
So that's, what type is that? Is that a series or?
Series, yes.
Series, so you can just do print reverse ages times 2, that's an order.
Yeah. All right. So let's have a break for 5-10 minutes, and then we'll talk about data. All right. So we'll continue with DataFrame. So we're talking about series, and so just as we were able to subset the series with a Boolean vector, so we can subset DataFrame with a Boolean. Okay. So we have scientist, which is a DataFrame. Okay. And we need to substitute with like a Boolean operation, right? So what we are saying, scientists, so print the records where the age in the scientist is greater than the age, or the average age in the scientist. So in here, so this is the title, we're gonna submit it, right? This is in here. So we're gonna calculate 2 values, okay, 2 vectors. The first vector is the age of the scientist, and the second one is a scalar value, which is the mean. So if the age in that vector is greater than the mean, print it. And that's what happened. So print it like 1, 2, whatever, only the records. So 1, 2, 3, 4, skip 4, 5, 0, okay, and 6. Okay, and printed all the ages that are above the average. So 61, 90, 66, the average about 59 something. Okay, if you do it, right? So you could subset with a Boolean expression in between, right? Boolean expression in between. Make sense? Right? So you could have absolute subnetting, like values, or you could have ranges, okay? Or you could have Boolean condition. So the data frame subnetting could be by a column name, single column, or you could have multiple columns, so multiple columns. That's given, right, by a column. And notice that when you have multiple columns, we put a set. So there's 2 brackets in here. You cannot put only 1, right? And you could use the lock, and you're gonna have the label. The lock could have multiple labels, and again, you put it in the list, so 2 square brackets in here. And you could have the index lock, or index lock for multiple rows. IX and IX, don't worry about them. They are used for in Python too. You don't have to worry about them. And then you could have a bool, or you could have multiple bool operations. Okay? Or you could have the normal way, which is a start, stop, and step. Okay? All of these you could use them for subnetting. All of these you could use them for subnetting. Maybe there's more examples in here. So format the born column as, okay. So for example, you have in here a function. This is a PD for panda. There is a method called toDateType. So we convert the string of the date to a format. So scientist.born. So this is a column which has the born. It's written in a certain way. Let's take a look how it's written. Born, written 1920-07-25. This is like an object, written like an object. object in Panda means string in Python. Okay, what's the problem with this string? When it's saved, when the born date or die date or any date saved as a string, what's the problem? You cannot do operations with it. So you have to save it like?
If you're comparing it with something like another integer.
So I need, for example, to know how long he lived. I could subtract this from this. But the problem, this is a string and this is a string, right? I have to convert it to a date object. Then I could use the built-in functions or the overload for the minus and the plus, right? So what we did, what we could do in here. Where am I? Yeah, in here. So there is a function called toDate. So first of all, I pick here the series of the board. Okay, it has all the dates. Okay, I format it to year, month, date, or day, and I use the method toDateTime. So now when I print born datetime in here, what is this object?
Date.
Date. This R date, right? All right, and I could do the same thing for the date, the date of the date. So now I could add these two columns or two series to the date. So what I do in here, scientist, born, date. So what am I doing in here? I'm adding a column to the data frame. Okay? Adding a column to the data frame. And here what I'm doing in here, I'm adding another column to the data frame, which is date. And where I'm reading it from two vectors. The first vector, which is born date time, and the other one, date date time, which I just created, right? I just created it here. All right. So when I print my data now, how many columns it has? It used to have 6. Now it has how many? 8. Name, born, die, age, occupation. Okay. And then I added these two, the born date and the die date. Right? I have them all two. Okay. What's the difference between this and this? These are string from object, and these are type. Okay. Clear so far? So now I could create another column which is age, days, date. Okay. So what I do, okay, so I'm adding another column. How I'm calculating it? So scientist died date minus born date minus. Can I do the minus? Yes, because these objects are what? Dates. Okay, and I'm adding another column called what? The number of days. So I see it here. I added a column which is age, days, date. That's the label of the column. It's in here. And calculated the dates the person lived. Alright, so now I have this data frame. How many columns has? 1, 2, 3, 4, 5, 6, 7, 8. I could add as I want. I could add many columns, calculated columns. Right? I could add whatever I want. Alright? So if I need to look at the columns, how can I know all the columns of my data frame? There is a shape and there is columns, you know, these attributes. So I have the name, born, died, age, occupation, born, whatever, until then. So how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Okay. All right. All right. So drop the, okay, if I need to drop a column, if I need to remove a column, now I added few columns or series. I could drop them. So how can I do drop? Drop. There's a function. There's a method called okay. Drop age from axis 1. Axis 1 means what? The columns. Axis 0 means the rows. So I could drop the columns. If I printed again the columns, the age is what? The age is gone. The age column is gone. All right? So exporting and importing values. Okay, pickle. What is pickle? Like a binary files. So when I have a file, usually I load the data. First of all, I could create data frame in my program, right? Program. All right. If I shut down the program, the computer, what will happen to the data? It will be gone, right? So I have to pickle it. I have to save it to a file. All right. Pickle is a binary file. I could save it to CVS. I could save it to a CVS, which is a text file, right? So, sometimes I load a file, like what we did in the beginning of this class. I do some work. For example, I added like more series to it, right? So I could save it back, all right? So Python has a way to pickle data. This is Python's way of serializing and saving data in a binary format. Reading pickle data is also backwards compatible. So for example, names, scientist name. So what I'm creating in here, a series. What does a series have? The names, okay? And what I could do, if I need to save it to a file. So what I have to do, names, which is a series, dot to pickle, and I give the name of the file. And the pickle file should be, the extension should be pk, could be pickle, okay? Then if I need to load it later, I could, read it later from pickle. So in here to pickle, so pickle, I'm saving it to a pickle, names to a pickle, and a scientist. What is scientist? Is a data frame. I'm also pickling it to whatever pickle, not pickle. It's like a binary file. So the same method is used for both series and pickle. Okay, I saved it in a pickle. I pickled it, saved it in a binary file. I need to read it back. Very simple. What I have to do, read pickle. There is a read pickle. At the beginning of this lecture, we use what? Read CSV, right? Now read pickle. Same thing. I could point to the file and I read it and display it. So that's what we do, right? I mean, we usually we work with a data frame. We do a lot of changes to the data frame or to the series. We need to save it somewhere. If I shut down the program, all my changes will be gone, right? We need to save it somewhere. That's what you do, all right?
You cannot use database like,
You could.
You can.
Oh, you can. I mean, this is just pickle as a binary file as an example. You could save it to JSON, for example, format. You could save it in many. I'll show it to you in a second. Okay, many options. You have CSV, CSV. Okay, is a comma or tab separated. The same thing. There is two CSV method and read CSV, right? So you could read and write to there. All right. So this is two CSV, and you could write a series. You could write a data frame to a file, right? And in here, if you need to, you could read also. You could to frame, for example, here to Excel sheet. Just you have to import a library. The library is import XLWT, and then you could save it to Excel file. All right. Just you have to be careful, okay, because Excel has a maximum size, the number of rows. So if your data is so big, some of the data sets you'll work with, it will have like 5 million records. No way you'll be able to save it in Excel sheet. I think Excel sheet could have 1 million quarter maximum rows, okay? So you have to be careful, all right? So you could save or you could read to Excel sheet. Okay, this is your question. So you could export to the clipboard of your computer to dense, convert data into regular dense data frame, to dictionary. you presume it's a small, okay. To Google big query table, you could have it to HDF, which is hierarchical data format, to MSG back, which is JSON-like binary. You could have it to HTML, save it in HTML, okay, directly. JSON for people who program web pages and all to JSON, right away it saves to JSON. To LaTeX, LaTeX is like formatting text. You could records to string, spurs to SQL. Okay, I don't know what kind of SQL, I mean, there's different database management, okay, but there's an option, okay, and I'm sure maybe there is more options than this also. That way you could save it too. So usually when you have data, a lot of data, so now we gave you a good introduction to data frames, to series, how to subnet, how to create a dictionary, how to create a data frame, how to create a series. Series could be created from a list. Data frame could be created from dictionary. Okay, you could subnetting, you could do some operations, you could add more columns, you could add more rows, you could do Boolean operations. You could do many things with in a very easy way, and it's easy to broadcast, right? So when you're doing operation in a vector with a vector, it will go element by element, for example, and so on and so forth. So it's a very, very, very easy to do it. Also, you could read it from different format. You could read it from a pickle file. You could read it from CSV file. You could read it from Excel file. You could write to Excel file. You could write to CSV. You could pickle it. Okay, so you could do all of that. So this data usually, use some work on it, and the best thing is when you do some work to visualize it. So that's why Python comes with a few packages that help you to plot the data. The most common one is matplotlib, and Seaborn it has. And actually the Panda itself has some graphics also built on it. Seaborn is the most statistical, mathematical, tool used for drawing these things, right? All right. So why data visualization is very important? Because the data by itself as a data sometimes it does not tell you the real picture. We'll give you a very good example for a set. So data visualization is much part of the data processing step as the data presentation step. So by visualizing data, we are able to get better understanding, okay, and better sense of the data that you are trying to look at or you are looking at, better than like table. Visualization can bring to the light hidden patterns. I mean, usually when you have big data like that, you'd like to look at the patterns. Okay, how is it? Okay. So the quintessential example of a creative visualization is some data called as comes a quartet. It's very interesting. So there is a quartet. There is 4 group of data, completely different data. All right, but when you calculate the mean and the variance and the correlation and the regression line, they are the same. So this statistician create this data. He was very innovative. He create this data set that they are completely different data. When you graph them, they look completely different. But when you look at these values, they are the same. So when you calculate, for example, the mean for all the 4, you will think, oh, this is the same data. It's not. They behave completely differently. All right, and you are able to figure this out by viewing it. Okay, so in this one, in English statistician Frank Anscombe ASCOM, I think that's how we read his name, ASCOM, to show the importance of statistical graphics. All right. So there is 4 sets, as I mentioned, of data, each of which contains 2 continuous variables, x and y, and they give you the same results. So look, this is his data. So the first set is called set 1, the second 2 set 2, set 3, and set 4. Each one of them is like 11 elements, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 times 4, 44. 44. And each set has 2 labels or 2 attributes, x and y. All right, x and y. If you calculate the mean, all of these, it will be the same. But if you look at the data, they are completely different. They are completely different. Let me zoom out. Okay, and this is when you plot this data, look how they look. Although they have the same mean, they have the same mode, the same median, the same everything, but the data is completely. This is data set 1, quarter 1, quarter 2, quarter 3. They have completely different. So that's the importance of visualizing the data. Okay, many times you could tell much more from the graph than the data itself. Okay, than the graph than the set. Nowadays, okay, there is a field called data science. I challenge you, get any newspaper or magazine nowadays, any day, in any field. If you don't see 1 or 2 or 3 or 10 graphs like this, I don't know anything.
You get a name?
Huh?
We get a name?
Yeah, don't get it from Brazil though. All right. So it's like everything now, everything about like graphs, everything they represent everything or present everything in a graph. All right. So that's what is data science. It's all about data. The life now is about data. All right. Even when McDonald's try to present something, they put some data for you. Dunkin' Donuts, Starbucks, colleges, universities, it's all about data, right? So it's a very important, look at any scientific paper you read, okay, you have to have such graphs everywhere. So it's a very important tool, very important that you are able to plot your findings, your data, all right? Maybe some of you use MATLAB, some of you use R language, which is like specialized for such a thing. Okay, Python also a very strong candidate for this. All right, it's a very strong candidate for that, and there are so many applications for that. Right? Think about the weather. Every day in the morning, ourselves, we look at the weather. Right? The weather. I mean, if this is April, right? I would like, for example, to know how the weather look like the rest of the month. If I'm gonna go check it day by day, it's too much work, right? A lot of work. But if just I look at the figure of April of last year or last 10 years, I will be able to see how is the weather will be compared to previous years. Or even if I look at the graph of April with the last previous months, for example, this year, I will be, so graph is a very important. Graphing the data is a very important. All right? Actually, a long time ago, they say that one figure worth 1,000 words. Graph nowadays worth like 1,000 tables. Okay, I mean not 1,000 tables, but it's much more valuable than tables. So let me go back. So this is our data. All right, we just show you. So basically, the way you do it, okay, Seaborn comes with the data sets, and the way to load the data sets come with it is very simple. Okay, first of all, you have to import the Seaborn. Make sure you import it, and usually we give it a nickname as SNS for short. SNS, right? And SNS.load dataset and is ASCOM. Once you import the module, all the data sets come with it. All right, there is a data set comes with it. Okay, So now it will save it for you in a data frame. So anscom, and here is a data frame. If I say print, anscom printed the data frame for us. Clear so far? So now we are working in what data set? In this data set now, for a while. Okay, this data set, which is built of how many columns? How many labels? 3. The data set, there is 4 different values. The x and y is a continuous values. So this kind of discrete, and this is continuous values, right? 2 values, right? And of course, this is the index, it's not a label, right? Very important to know how to use matplotlib. So matplot is Python's fundamental plotting library. Okay, you'll find yourself importing it all the time. It's extremely flexible and gives a user full control over many elements of your graph, and you could do many different graphs. Importing the library is a very important. Okay, and basically when you import it, it's import matplot.pyplot as plt. So always you give it a nickname as plt or a short as plt. And we don't import it alone, we import like some package which is pyplot. So myplotlib and .pyplot. So just do it like that, without, you know. Okay, the name of the most of the basic plot is plt.plot. What is plt here? It's the nickname for the module. And the plot is what? It's a function, right? Okay, so for example in here, okay, I have a data set 1 from the anscom data set 1. So I'm trying to pick only these ones. The data set is number 1, right? Okay. And plt, which is a shortcut for the library, plot. What I'm plotting the data set, okay, of x. So this is x, and this here, I'll have the x, and then here I have the y. Okay. So by default, we'll draw like bars, like a continuous, right? So that was the figure. All right. So if you look, for example, let's go back. What is the first element? 10 and 8.4. So in here, the beginning you see in here, this is 10 and 8.4 in here. Then go to the next point. What is the next point? 8 and 6.95, which is in here. This is 8, 6.95, and continues until it draws all of them. So very simple. In 2 lines, you were able to draw the first data set, which is 2 variables, x and y, and that's the drawing. All you have to do is call the library, plot, put the x value and the y value. Right? Clear? Clear? I mean, this is not very representative. Usually what we try to put dots, right? Circles. And instead to make it more clear, very simple. So all you have to do the same thing. The only thing I said is draw a circle, not bars. So now, this is the first one in here, for example. Okay. So how many data values they have? How many pairs they have? 11. Are you still sleeping or 11? Right. So if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Draw them for me. This is values coming from where? From the x, and this coming from the y. One line, I was able to draw this nice plot. One line. All right. So basically, if you have a data, forget about this data, which has x values and y values. Put the x values in one list and the y values in another list and call this. put the first list in here, the second list in here, and you'll be able to plot it very simply. Very simply. So figures can be created with multiple subplots. This is multiple subplots. I have, how many quartets I have? 4. So this is the first quartet, okay? The second quartet, the third, the fourth. As we said, it's completely different shape, different trends. So that's why it's a very useful to have the graphs plotted, right? So to improve the graph visualization, labels can be added. So in here, for example, okay, we have the title. You could have, you know, the things added. All right. So data could be univariant, has one variable, two variant, and multivariant, right? The graphs, univariant that you're drawing one variable. Two variant, like what we did, x and y. And the graph could have multiple variant. Show like 3 elements at the same time, or 4 elements, or 5 elements. It becomes much more complex. The easiest thing, the easiest plot you could have is what? Histogram. So histogram, it's a univariate. It's a univariate. Histograms are the most common means of looking at the single variable. Okay, the values are bent. You create bends, okay, meaning they are grouped together and plotted to show the distribution of the variable. So in here, what we do, so basically when we draw, okay, we're gonna, the first thing we have to create a figure, something called figure. What we call this? A figure. Inside the figure, we're gonna create axis with E. And each axis will have 2 axes. Axis and axis with I. It's very confusing, the 2 axes. Okay, the 2 axes, completely different meaning, the same pronunciation, different writing. All right? So a box, the bigger box is a figure. It could have 1 or more axes. So it could have, for example, 4 axes like that. And inside each axis, what we have? The plot. The plot. So we have a figure. Inside the figure, you could have many axes. And inside each axis, you could have plot. The plot, though, could be inside an axis or could be directly inside the figure. So if I would like to have multiple plots, I have to create, in one figure I have to create axes. If I have one plot, I could put it in one figure. Clear? Kind of? Okay, comprende? Okay.
You have to have a figure that, yeah.
You have to have a figure, anyways. Okay, so let's take a look. So the first thing is, there is a function called figure. PLT is the shortcut for the library, figure. So what is figure here? Is a figure. So the first step, I have to create a figure. If I execute this, without this, what will have? I'll have an empty box, which is the figure. Right? Now, I need to add a subplot where to axis 1. So I have an axis 1. Okay? So in here, axis 1, it's like row 1, column 1, and it's occupying position 1. So this figure has how many axes? 1. 1, right? Because I have 1 row and 1 column. Okay? I could have a figure like that, a figure, and it has 4 axes. So how can I reference them? This is 2, this for example, 2 times 1. This 2 times 2 times 2. How about this? 2 rows times 2 columns. What the location is? 3. This 2 rows times 2 columns. What's the number? 4. 1, 2, 3, 4. When I say 1, 1, 1, so that means row, 1 column, and the number is 1. So that means this figure has how many axes? 1 axis. And this axis, how many plot has? 1. One axis, the axis cannot have more than 1 plot. Alright? So what I did in here, figure, in here the figure, I'm going to the figure. So I'm telling you, for this figure, I'm adding a subplot at this location. And I'm calling it what? Axis 1. Now I have to tell the axis what is the figure. So axis 1 dot histogram from the tips data set, I'm only picking what? The total tip, total bill. And how many bins am I creating? 10 bins. 10 bins, all right? And then I'm setting the title. What is the title? Histogram of the total bill. And what's the result? Here you go. So how many bins I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because I said so. I said I need how many bins? 10. All right? And where is it coming from? From the total bill. From the total bill. So created in here is how many variables I have in here? 1 variable. What's the variable? Total bill. Okay? So, for example, the value, for example, the bill, for example, like average in $30. How many we have frequency? 20. 20 bills in the data set has $30. How about 40? About 10. Okay, in here like $15, about 70 bills has $70. That's what the histogram. Yes.
If it's only that wasn't it only analyzing 1 row?
1 row, 1 variable.
So I don't get it. So is that the same plot from that code?
So in here the total bill.
Okay.
Okay, there is a data set has the total bill, the number of parties in the morning or the evening, the total tip. Okay, data. Okay.
Yes.
So we looked at one column, which is the total bill.
Okay.
Okay, the total bill, and this is in dollars, right?
Mm-hmm.
Okay, and this is the frequency. Histogram tells you the frequency.
Okay.
Okay, tells you the frequency, right? So for example, in here, the total bill about like $43. How many is about like 10 people?
So it's basically analyzing the entire column and see how
Exactly, the entire column. We are trying to see, for example, how many, for example, from $5 to $10. I'm sorry, how many from, for example, $0 to $10. How many from $10 to $20, $20 to $30, $40, $50. Okay.
So what's the meaning of the first one in the subplot? So figure.add subplot, and then the first one, the first item.
Here?
The second line. Figure.add subplot, and have 1, 1, and 1.
I already explained that. So
Yeah.
in the figure is like a grid.
Okay, yes.
So the figure could have like 1 by 1. That means how many? One plot.
Okay.
If you make it 2 by 2, how many figures you could have?
2 figures.
4. 2 by 2, like here. 2,
Okay.
2 by 2.
Okay, so that's okay.
If I make it 3 by 3, 9. And that's how we number them. Let's say 3 by 3. It will be 1, 2, 3, 4, 5,
Okay.
6, 7, 8, 9, right? So in here, I'm creating one figure and it has one axis. So it's 1 row,
Okay.
1 column. What's the number of the square?
1.
1. Could it be 2?
No.
No. All right. If I make it 1 by 2, what are the options I have?
1, 2.
1 or 2. If I make it 3 by 1, what are the options I have?
1, 2, 3.
1, 2, 3. Exactly. All right. If I make it 2 by 2, 1, 2, 3, 4. So it's like a grid where you could paste the subplot. So you have to create the figure. Inside the figure, you have to create the axis, okay, or the axes. So the figure could have 1 or 2 or 3 or 5 or whatever number of axes. And inside each axis, you have to create what? The subplot, the plot you would like to do. So in here, the plot we need to do, in here it was histogram. And that's what we had in here.
Got it.
All right? And, I mean, you said you got it. I'm telling you, if you try it, I'll believe you got it. Okay? Because as I go now, you're going to get more confused. There's so many plots, so many options, and the only way is to try them. Okay? So please try them out. All right. So bivariate, that means like you have bi means 2, right? Bivariate, like one of the common drawings after histogram is the scatter plot. Scatter plots are used when continuous values is plotted, like x and y in our example. Like they are continuous values. What does it mean continuous? Could be any value. What discrete means? Specific value. So for example, the gender, is it discrete or continuous? Discrete, male or female, right? Right? How about the height? It's a continuous, could be many values, right? It could be 6.5, 7.2, 4.3, it could be anything, right? So scatter plot is for 2 continuous values. So look in here what we did. So what is the first thing we have to create? Figure. And we named the figure as a scatter plot. You could name it anything. You could name it Abuznit. You could name it John. You could name it anything. So we created the figure. So we created the bigger box. Then after that, I created one axis inside it, which is a scatter plot. This is the name of the figure. Add a subplot, and how many boxes it has? 1 box. 1 row times 1 column, that means 1 box. Put it in the 1. Then what I did in here, scatter, tips, total bill. So this is bivariate. That means how many variables it has. Bi means 2 variables. And the 2 variables has to be discrete or continuous. Discrete or continuous. Continuous. So I'm drawing total bill against tips. So if the total bill is how much is the tip? All right? And then I'm giving it a title, X label, Y label, and then I have to print show to show it. Look in here. So that's what we did. So what you have in here? Total bill. In here, the tip. What is the X label? Total bill. What is the Y label? Tip. What's the figure title? Scatter plot of total bill versus tip. Where these came from? Where these came from? From here. From the axis, X label, Y label, and the title. Very simple. So I was able to create a very nice graph from how many lines? 1, 2, 3, 4, 5, 6, 7 lines. Very nice. So the first thing, you create a figure. Give it a name. PLT figure. Give it a name. Any name. Then from now on, I'm working with figure. I have to call it every time. So I'm going to create an axis, a scatter plot, which is the figure name. Add subplot in a certain location and give it a name also. The axis name. So axis 1. Could be anything. Could call it anything. Okay? Then axis 1, you're going to add to it a scatter. What is scatter? Is a plot. Alright? And then you finish. So the first thing, we create a figure. Inside the figure, I create axis or many axes. And inside each axis I have to create a plot. This plot could be what? Histogram, scatter plot, violin plot, box plot. Any plots, there's so many plots. Exactly what you want, right? But that's the other thing. It's very simple. So, box plot. Okay, let's take a look at box plot. So what is the first thing I have to do one more time? What is the first thing I have to create? Figure. So BLT figure. And I give it a name. I give it box plot. Then after that, I have to add a subplot. So how many axes I have in this one? One axis. I give it a name. This is axis 1. Then axis 1, I have to put inside it what? A plot. Which plot I'm doing now? Box plot. Box plot. Okay. Box plot. First argument of the box plot is the data. Since we are plotting multiple pieces of data, we have to put each piece of data into a list. So for example, in here, for example, in here, tips. Okay. Tips, the gender equals female. That's for the female. And that's for the male. Okay. All right. And I gave it a label, female and male. And then what I call this is a box plot in here. So the first item is the male, and the second one for the female and the male, and then the labels female and male. Then I put the X label, the Y label, the title, and then the show. If I don't put the show, it will not be displayed. So always I have to call X plus the show, and that's what I have. So I have the female and the male. Okay. Do you know what's a box plot? Box plot is one of the plots, okay? Okay. So this will show you the minimum value, this show you the maximum value, and then here show the outliers, and this is the line is the median, show you 5 values. And this are the 50% of the data within the plots. So the 50% of the data is between $2 and $4 for the female, and between $2 and kind of $5 for the male. 50% of the data. And this is the median, and this is the median. This is for the female, this is for the male. This is the minimum, this is the maximum. And these outliers. That's what the box plot. It gives you certain information.
Like on Canvas for the grades.
Yeah?
For grades assignments, they use a box plot.
Readable? I do not know. There is?
Yeah, it shows like the low grade, the high grade, and then the median.
Yeah. But is there a box like that? Box plot?
This way.
Nice. Alright, so far so good. So we learned about histogram, we learned about scatter plot, and now we're learning about box plot. Alright? So now, how many variables we are drawing in here? 2, right? One is continuous and one is discrete, right? The gender is discrete. The money is continuous, right? How about in here? How many variables? How many? 2 variables. Continuous and continuous, right? How about in here? One variable, and which is continuous. Continuous, right? Right. And this is like discrete and continuous. How about if we're trying to have draw multiple variables? Multiple variables. So look at here and here. How many variables we have in here? How many variables we have in here? Who says 3? Who says 4? Who says 4? See why?
There's total, bill, tips, sex, and
size.
Perfect. Thank you so much. So you have one continuous, and you have the color is another variable, and the size of the dot is another variable. So how many variables you draw in here? 4. I don't have the legend with this, but the blue has a meaning and the yellow has a meaning, right? And the size could have a meaning. Right? So in here, create a color variable based on sex. So sex means gender here. So for example, could be the yellow. For example, the yellow could be female, and the purple could be male, or vice versa. So in here, I look at this. This is like total bill is 30. Then the tip for a female or male, female, from the color. I could know from the color. The size of the circle could tell me the size of the party. So this is, for example, a large circle. That means maybe there's 5 people in the party. Right? Okay? How many people, right? So in here, record sex. If sex is female, return 0. If it's 1, return 1. So this in here. So in here, tips. 6 color, I'm adding another column, 6 color, tips, 6, and apply a function. Which function I'm applying? This one, okay? So then what I'm saying, scatter plot, I'm creating the first thing is the figure. And then after that, axis 1, scatter plot, adds a plot. How many axes I have? 1. I have 1 box, right? What is the name of the plot? Scatter. And in here, X is the total tip, and Y is the tip, and S is the size, which is the size of how many party, right? I mean, the part is 2, 3, 4, 5. Okay, and multiplied by 10. The diameter of the circle. Okay, diameter of the circle. And then C in here is a color. So what is the color will be? Either 0 or 1. Alright? And then I create like the shade alpha, then the title, the label, and then the show. And that's the color I have. So this, any dot in here, I mean, for example, this dot, what does it tell me? It tells me the total bill, it tells me the tip, it tells me yellow is like a female, and it tells me the size of the party. All right. What do you notice in here? I mean the color. The color is very obvious. Tell me the information. But there is a problem with the size, right? Because usually when you calculate the size of the circle, it's proportional to what? To r square, diameter square, right? So it's a very hard to give you like a very good indication, although we have it in here, but it's not recommended to use, right? Because the size is not straight size. It's like by r square for the size, right? And that's why it's not really clear. It's not clear, but the colors are clear, right? Tips are clear. Total bill are clear. So you have to be careful how you decide to, okay, you could play with the who also, right? So Seaborn comes with its graphic or plotting. What we used before, it's from Matplot. Okay, for statistical and mathematical, Seaborn is better. It has better, although it's built in the MATLAB. How many minutes I have? Huh?
5 minutes.
What time the class finishes? 3:45. Okay. All right. So Seaborn built on Matplot by providing a higher level interface for statistical graphics. Okay, it provides an interface to produce a prettier and more complex visualization. All right. So it's used like for NumPy, the Pi data, NumPy, SciPy, you know. So we'll take a few quickly. Of course, I mean you have to import. So import the C port, and we give it the nickname SNS, right? And we need to load the data set tips. So load data set tips. It comes with it. When you download the Pipit, it will come with the data. So now tips is what? What is tips? Huh? Data frame.
Yeah.
Data frame, right? Tips is data frame. We load it in a data frame, right? I was expecting somebody to tell me tips are money. Yeah. So again, you could have in here univariant, bivariant, and multivariant. Okay, but different libraries now. Just we have to take a look how it goes. So univariant, for example, in here. So you don't have to create the figure, and the axis in two lines like we did in Matplotlib. In one line, you could create it. So when you say, for example, PLT subplots, this is the axis and this is the figure. So this subplot function is a shortcut for creating separate figure object and adding individual subplots axes to the figure. Okay? So this is the axis, this is the plot, right? So what you do, axis, which is the axis, distributional plot or dist plot. Again, you are drawing in here total bill. So it's like one variable because it's a histogram, and then you sit in the title. Look, it's different. Like in a way, you have to be careful how to use how you call the functions, different functions than before, right? Because this is a different library, right? So AX, which is the axis, set library, give it a name, and then a show. And when you draw it, it will give you like that. The only difference, by default, it will give you this, the histogram, and it will give you the density plot together. You see, I mean, in Matplotlib, it does not give you both together, give you one. In here, it will give you together. Okay, this is the density plot and the histogram together. Same thing, right? Same data. If you look, it will be the same data. So if you really don't want the density gram, so density, KDE false, it will remove it for you. So the same thing, if I need to remove the KDE, okay, I do it like that and it's gone. It's gone. The other thing, you could add things to it. So in here, you could draw this by itself. So in here, what you did, the histogram false. I need to have the KDE, but I made the histogram false. So by default, I will draw both of them. You could choose one of them by making the other one false. Good? Good? All right. So that's what we did, the same thing, univariate or univariate. Then also it will give you a rug plot. I'm not sure how it's useful, the rug plot, but let's presume it's useful. So rug plots are one-dimensional representation of the variable distribution. They are typically used in the other plots. So for example, in here the same thing. So plot, subplots. It will give you the axis and the subplot. So the axis, distribution plot, tips, and you say rug equals true. Rug equals true, okay? And when you say rug equals true, now what you have the rug in here? The distribution. That we call it rug plot. So in here it has three plots: histogram, density, and density graph, and rug plot. Could have three of them together, one of them, two of them. It's your call. Okay. And this is part which library? Seaborn. 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 So the count plot or the bar plot, okay, bar plot is not histogram. Bar plot. Bar plots are very similar to histograms, but they are not the histograms. But instead of pinning values to produce a distribution, bar plots can be used to count discrete values. count discrete values, to count the discrete values. Same thing, how you start PLT and subplots. You're gonna give me the axis and the plot. What is the plot? Name, counter plot. Counter plot means what? Bar plot. In Excel, we call it bar plot. Most of us, we call it bar plot. In Python, what do they call it? Count plot. Why is it called the count plot? Because it counts. No, it's not. I don't know. I know. Okay, because it counts the discrete elements inside the discrete variable, right? So, what we gonna count in here? The day. So in that data set, we have the days: Sunday, Saturday, Monday, whatever the days. So we need to know for each day how many people, how many people in the data set. So what is the data? Tips. Data is tips, which is a data frame, and the day. And this is the title, the label, and the show. And here it is. So in the data set, I have 4 days. I have Thursday, Friday, Saturday, Sunday. All right? So this is bar, what we call it a bar figure, or count figure. So in Thursday, how many? About 62. Friday about 20. Whatever. Saturday about 90. Sunday about 80. Okay? Easy, right? Can we do in Seaborn scatter plot? Scatter plot, can we do? Of course, there's all right, scatter plot. Scatter plot is univariate, variate, or bivariate. Bi or uni? Uni, scatter plot. Just read the slide. It's bi, right? It has 2 variables. What kind of the variables? X, Y. What they are? Continuous or discrete? 2 discrete values, right? 2 discrete, right? Values. I know you are tired by now. All right? So discrete values, right? All right. So very simple. How you do it in here? Again, plot, subplots, the axis and the plot name, and we call it regular plot. It has 2 values: the x, which total bill, and the y, the tips. Okay, and the same rest. When you look at it, here you go. What is the difference between scatter plot in Seaborn and scatter plot in Matplotlib? Is there a difference? It gives you the regression line by default. This line we did not have before, right? It gives you the regression line. See the line here? Okay? It does not give it to you before. There is also Higgs-Pin plot. Higgs-Pin plot. Okay? So it's a bivariate, of course. Scatter plots are great for comparing 2 variables. However, sometimes there are too many points for scatter plot to be meaningful. Too many points. So how about if we group the points? Group them, right? Right? So just as histogram can bend the variable to create a bar, so the aggregate for a histogram was a bar. Combine them. And the aggregate for scatter plot is the Higgs-Pin. Okay, where you could bend 2 variables. So hexagon is used for this purpose because it is the most efficient shape to cover an arbitrary 2D surface. Okay, so the same thing. If we call it, you call it join plots, and anyways, so it joins like this scatter, and you could have in here. So it's like histogram for the tip, and like and histogram for the total with here and here. there is 2D block also. Just take a look at the log. My time is up, so I gotta go fast. So this is like 2D density plot. All right. Same thing. Same thing. Okay. There is a bar plot. Seaborn bar plot. Do it. There is box plot. Just follow the code. Box plot. Very nice, right? You could have a violin plot. Okay, violin plot. The same thing, not a box, but this also, it will give you the shape of the distribution. Okay, it has the same elements, but the shape of that violin plot. There is pairwise relationships. You know, you could create, for example, in here. So in here, for example, total bill with the size, total bill with tip, total bill with a total bill give you the histogram because it's one variable. So I mean, this and this two variables. If it's univariable, it's gonna give you that histogram. So that's why in here, what do you have? The histogram. You got one variable, right? So you have like total bill, the tip and size drawn together. So this is total bill, okay, with the size, okay, and size in here with total bill. Okay, you see this, how it is? So this is like this, and this is like that. Because it's the same graph, but you changed what is in X, what is in Y. Right? So look at this and this. Like a mirror, right? Okay, so this in here, tip and size. Tip and size in here. So this and this like a mirror. Right? And this like a mirror. Right? And this is like histograms. Right? So put pair them in order. You could play with the colors as you wish. You change the color, for example, in here, the who. Okay, the who. So in here, how many variables you have? 3, 4. So you have the total bill, which is a continuous. You have lunch and dinner, and you have the color tells you male and female. Right? 3. Same thing in here. We have like maybe 3. In here you have 3, yes. You could play it. So the size and the shape, you could play with it, make it more size and shape. You could have facets. You take a look at that. Okay, facets with the 4 colors. Okay, and also you could draw with pandas. So the first group, it was from which library? Matplotlib. The second group from Seaborn. The last group, which is in here, from pandas directly. Okay, so I mean what we covered. This is the simplest of the most simple graphs you could have. I mean, you could have so complex graphs that you could do. So this is, for example, this is a histogram. All you have to say, DataFrame plot histogram, and that's it. So for example, in here, axis, tips, total bill, plot histogram from Panda. You did not even call any other library, and it will give you the histogram. All right? Maybe it's a little bit limited, not option. In here, so you'll have to say plot KDE and give you the KDE from Panda. From Panda right away, right? Scatter plot, the same thing. What you did in here, tips.plot, scatter plot, and you put the parameters, give you the scatter plot. Maybe for a simple drawings like that, the best thing is to use from Panda. You don't have to go crazy, but you cannot format it, right? You cannot format it. Usually, when you're writing a paper and try to publish something, you try to put like 4 figures together. So you create a figure, then the axis, 3 axes, whatever, and you put it. You have more control when you use Matplot directly. Okay. Okay. That's the hex pin, plot, the box, okay, plot, the seaborn themes and styles. Could have different styles. There's 5 different styles. Look at the styles. So this is the dark grid. This is the white grid. The dark style, like the background, or the white, the text. All of these slides are available. Okay. All right. So today I think we have covered a lot of stuff. All right. That concludes the lecture. So we introduce you to Panda, the series, the subnetting, how to use it, how to load it, how to save it to the file, and then these like data frames have a lot of data. At the end, you need to draw them. You need to plot them. You need to plot the data. We'll learn about different libraries, how to plot them. All right. See you next week.